Cramer's rule with two variables. This is when we have two systems of equations, each having only two variables at max. So for this first example, we have the first equation is 3x minus 2y equals 7, and the second equation is 2y equals x plus 4. For step 1, we need to get it to where x and y are on the same side and the number is on the opposite. So the first equation is already done. It already has the x and y on the same side and the constant on the other. But on equation 2, we have this x that needs to move around. We need it on the opposite side, so we'll subtract x from both sides. So we have negative x plus 2y is equal to 4. Now I have my two equations I can work with. I'm ready to go to step 2. So now, in step 2, I am going to come up with my different matrices. And so, my coefficient matrix is a matrix that is made up of just the coefficients in front of x. So in my equation 1, in front of my x and y, excuse me. In my equation 1, I have a 3 in front of my x and a negative 2 in front of my y. And in equation 2, I have a negative 1 and a 2. That's my coefficient matrix. My second matrix I'm going to create is my coefficient matrix with the x replaced. And what that's going to be is I'm going to keep my y, but change my x. And what I'm going to change my x to is I'm going to put my x's to these two numbers. So that's going to be 7 and 4, but I'm keeping that negative 2 and 2. And so let's do that again, but this time we're going to do the coefficient matrix for y. So this time I am going to keep my x, but change my y column. And so my x was originally 3 and negative 1. I'm going to change my y column to that 7 and 4. Now I have my two variables. So this is step 2. On step 3, I am going to find the discriminant of each of those. And so when I find the discriminant of each of those, I'm first going to find my discriminant of the c. And so when I do the c discriminant, that means that I am going to take the 3 and negative 2, negative 1 and 2, and I'm going to do the downs minus ups. So my first down is 6, my first up is 2. So downs minus my ups gives us a total of 4. We're going to repeat this process for each of our coefficient matrix, the coefficient with the x replaced and the coefficient with the y. So let's do the coefficient with the x. That's going to give us the 7, the 4, the -2, and the 2. So when I do my downs, that gives me the 14. When I do my ups, that's when I get the -8. So we have 14 minus a -8. That changes into plus, which gives us the 22. Now my last one I have to work with is my CY. And so my CY, the discriminant of CY, C sub y, is the negative, or excuse me, 3, -1, 7, and 4. And so my downs are -12, or excuse me, +12, and my up is -7. So 12 minus a -7, those change to plus, gives me 19. Now that I have step 3 done, I'm going to step 4, and step 4 is the easiest step. So in step 4, is when we're actually finding out the ordered pairs. And so when we create our ordered pairs, the rule is x is equal to my c sub x, that discriminant, divided by my discriminant of c. So in our case, c was 4. My c sub x was 22, which can reduce to 11 halves. And then we're going to find y by doing my c sub y, that discriminant divided by my c, the discriminant of the c. And so that's going to be divided by 4. This time I'm dividing 19 by 4, and there's nothing that can reduce on that. So that one's done. Now I have an ordered pair. 11 halves, comma, 19 fourths. This is the reason it's a little bit nicer to be able to do it this way versus with the traditional way that we were doing, solving with elimination or with substitution or graphing, because they do tend to work more along those lines. You're not going to be working with the fractions till the end. But when you have two equations and you're trying to find out where they meet up, sometimes they don't when you have a parallel lines, or whenever you have them mapping to the exact same line. And so when they were the exact same line, that meant that it was infinitely many, and when it was parallel, that meant no solution. And so let's look at one that's going to create, I'm going to go ahead and tell you, this is going to create one where the lines are exactly the same. So we can see where those rules come into play. So in this first equation, I need to rewrite it to where x and y are on the same side. So I need to move the x over. And that creates a new equation of negative 3x plus y is equal to negative 7. And so now I have my two equations. And I'm going to use these to create my matrices. And so my first matrix C is my coefficient matrix, remember, x and y. So negative 3, 1, 6, and negative 2. My second coefficient matrix is a coefficient matrix x. I change my x values to where they are these numbers over on the right hand side. And so that's going to be the negative 7 and 14. But I go ahead and keep my right hand side just like it was. And then I'm going to do my c sub y. Again, I'm keeping my x this time, but changing my y. And my y is going to become that negative 7 and 14. If you want to, instead of writing these out as matrices, if you want to write them out as the determinants and kind of skip from this step to the next, that is fine. But just realize that if I ask you for the matrix, it needs to be in the matrix format. So that's step 2. Now let's look at step 3. We're going to find each of those matrices. And so when I plug these in to find each matrix, I'm going to try to find the determinant, not each matrix, each determinant. I'm going to find the determinant of C. And that's negative 3, 1, 6, and negative 2. So when I do my downs, which in this case is 6, minus my ups, which is 6, and I do 6 minus 6, and that becomes 0. Now let's do it again for my CX. This time I replaced my x terms with negative 7 and 14, but kept my y terms with that 1 and negative 2. And so I do my downs. So in this case it's 14 minus my ups, which in this case is 14. So 14 minus 14 gives me 0. And the last one we have is when I replace my y's. And so the determinant when I replace my y's is going to be negative 3 over 6, and then the next column is going to be negative 7 and 14. So doing my downs, 14 times 3 is going to give me a negative 42. and my ups are going to be positive, or negative 42 as well. And so when I subtract those, negative 42 minus a negative 42 gives me a 0. Okay, so now that I have those, if I go on to step 4, step 4 says I need to take this information and divide. And so it says that to find x, I need to take the determinant of c sub x divided by the determinant of c. But in this case, that's going to be 0 divided by 0. And dividing by 0 is undefined. But that's not a possibility. We can't give the answer of undefined. It's either no solution or infinitely many. And to figure out which it is if your determinant of c sub x or c sub y equals 0, it is infinitely many. If neither equals 0, then it's no solution. But you only do this test if c equals 0. So this, you must have the determinant of c equaling 0, or you cannot do this test. Only if the determinant of c is equal to 0 are these a possibility.